Okay, thank you very much, everyone. I actually have to disappoint Niels because even tonight he's not going to see the talk he actually originally signed up for. So I'm sorry about that. I actually decided to throw the talk around this week, which was kind of a silly idea because the first time I did the talk I had like 3 months to prepare and it took me all of the 3 months. So I changed it up a bit, but I left some things intact. I hope you enjoy. Okay, so what I did for Brew.js, I signed up for the conference and I wanted to talk about the NES. So so this is a relic of Brew.js and I cherish it very deeply. And I use this intro for the slides to Node Interactive, but I'll come back to that. So this talk is called 2016, the final talk, because I thought if this is going to be the last NL HTML5 meetup, this is going to be the final talk. Maybe not the one that I give, but this is going to be my final talk of 2016. So it's going to be the final talk and it's called Doing Hard Things is Easy. Because I find that when I'm doing hard things, I have a tremendous amount of energy to do those. Where if I'm doing really easy things, So 2016, what a year. If you look back on it, the world is on fire. I mean, what on earth is going on even? Like, all around the globe things are happening, which I don't really have an answer for, and I have no idea what the future is going to hold, and I have no idea what people are going to vote in 2017 in the Netherlands, and so some of it scares me, and I hope everything's going to be fine, but I feel like the dog sitting in the fire room saying, this is okay, this is fine. But by now I realize this is not fine, we're on fire. So 2016 was a strange year globally, but for me personally this is also a very strange year because I stopped basically doing all the things I did. I stopped working for Nederlands Schuurmans, my employer, for the last 4 years. I stopped doing the Utrecht.js meetups, which I did for 2 years. I transferred that to someone else, so it's not like that is gonna die. So if you need a place to have a warm welcome and a home after NL HTML5 is gone, you can go to Utrecht.js. It's exquisite. So I became a father this year. I started making sourdough bread, and I do it like every week. I bake super many loaves, and people get very annoyed because now I'm just like, hey, want a loaf? It's like, it's even worse than showing like your pictures of your child to people. Like, they're like, yeah, okay, okay. So I'm doing both things now. So beware, don't become friends with me. It's horrible. And I did some conferences this year, and this was actually a thing I did for the first time. I visited conferences in the past, but this year I attended conferences as a speaker, and that was kind of a game changer for me. So 2016 for me was a intense year as well. I started NES development, which is interesting in itself, I think, because it just takes a very different mindset to program for the NES than to do JavaScript for a browser with, I don't know, this machine has a 16 gigabits of RAM, which is super easy to write things that don't destroy the machine. Also, this is the first time I own a Mac now. I also don't know the shortcut keys, so if things go sour, just think of the sourdough bread. Okay, then, and I started teaching. So I quit my job, my day job, and I'm now a teacher. I'm a lecturer at the Hogeschool in Arnhem, and I enjoy that very much. Okay, so conferences. So I did this talk, the NES talk, about developing NES software with JavaScript. And I did the talk and I prepared like crazy. It took me like super much time, way too much. And I also found out that if I prepare really hard, things get better. Like, this was a realization for me that was kind of astounding, but I'm also in a band and we never practiced, and then we just like rocked up at the show. I was like, ah! And it was fun, but then when we prepared, it actually sounded better. Whoa. And the same for the talk. I prepared like crazy and it was better than all my talks before. So I did this talk, and I made a ROM that actually runs on a NES. So you can like put this in the NES and you can see my slides showing up there. So if anything, I at least made PowerPoint for the NES. Okay, so I did the Brew.js conference. This was my opening slide. and if I would open it on an actual NES, the screen would start to flicker with the like neon colors going through the whole palette of the NES, like, and it would be very intense if you were epileptic. So I'm not going to show it here because some people do have seizures. I'm sorry for that. But so this was my opening talk, and it was for the Root.js, and it opened up something completely new for me. I talked at Node Interactive Europe as well, thanks to JP Wesselink. I don't know if you know him, but he was almost like, I don't know what you call it, an agent for an artist. He was like, yeah, you should really book this guy. He's really great. And I was like, no, please, come on, don't. But then, like, he did that, and people started accepting me for conferences, which was great, because now I could also go to Tokyo. So I went to Tokyo this year. I went to Node Festival, and it was great. I did the talk there. And how did this happen? Because I had a silly little idea. I wanted to build a NES game, and I thought, okay, if I do build a NES game, I should probably force myself to really do it. So I handed in a talk to different conferences where I said, I will show you how to build a NES game with JavaScript. It's a super bad idea because that's why I had to work so hard. Because it wasn't finished at the time I handed in the talk. So I thought, let's build a NES game. How hard can it be? Pretty damn hard. So the NES is a machine which is constrained to today's standards. It has a CPU that is very similar to the 6502 CPU. I don't know if anyone knows what the 6502 CPU is.
Yes. Micro.
Exactly. So things like the Commodore 64 ran the 6502 CPU, and it had a very similar architecture to that CPU, except for a few things. Like it had built into the CPU, it had an audio processing unit with which you could make synth sounds. So it had 4 channels that do synths, and 1 for like noises. So all the sound like beats are with a noise channel. So if you still want to make like 8-bit retro music, the NES is actually a pretty great device to do that. Besides the CPU, it also had a PPU, and this was what really set the NES apart. I mean, the CPU by that time was around 10 years old. So really, 10 years old. It was just like dead cheap, so that's why Nintendo bought it. And they didn't actually want to pay the patent, so they changed it just a little bit. And then what they did do, they added the PPU, the Pixel Processing Unit, what we would call a GPU by now. And what was really great about it, it was able to do a background that moved, like either vertically or horizontally. Yes, not and, either. So either horizontally or vertically, or with like some magic tricks, you could do both. But like platformers would only move sideways, or in the next level they would only move like up. If you pay attention, you will see it. And otherwise, like games like Mega Man are just insane. I have 2 of these chips, but Mega Man has like a whole block of chips just to make that game possible. It's just a crazy game. So Mega Man is actually it's fantastic. You should all play it and learn to love it. It's difficult as anything. I can't swear, right? No. Yeah. Okay, so it's difficult as anything. So with a PPU, you could do background scrolling, and you could have different colors. So every character and every background thing could have different colors at different times. So yeah, there were only 64 colors, as I mentioned over there, but it had duplicates. It had like 7 blacks, and then on the NTSC device, it had another black because NTSC devices couldn't display the color properly. So in Europe, it would show up as like dark blue, and in the US or like South America, it would show up as dark blue. So yeah, 64 colors with duplicates, so only 54 colors actually. And then it had only 2 kilobytes of RAM, which is yeah, you know, it's there. Then the screen display, it only had a resolution of 256 by 240. On NTSC, that was different because NTSC would have a faster frame rate, so it would have to draw all the frames quicker, but it couldn't do that, so it was a little bit smaller and it could still do that. So I think NTSC runs at 60 frames per second and PAL runs at 50 frames per second. We don't have this difference anymore because now we have LED TVs. Yeah, so 3 colors per sprite. So you would have 54 colors available, but at one point in time you could only use 3 colors per sprite, because one of the colors that you would use for the sprite is the background color, and the other 3 colors, well, it just couldn't deal with more. So again, Mega Man is the exception, because they have brilliant programmers and some brilliant architecture. And they have like some, I think they use 6 colors, because the face is a different sprite than the body, but it's pretty special what they did there. So normally it's 3 colors per sprite. So if you look at Super Mario Brothers, he only has 3 colors at one, like always 3 colors. Either he has the white, what do you call it?
Overalls?
Overalls, yeah. Either the white overalls or the blue overalls, or the green overalls if you're Luigi. So, but it's 3 colors all the way. Also in Super Mario they had some little tricks with the clouds and the bushes.
Yeah.
They're the same sprites. It's pretty cool. Just different colors. Okay, so and you only have 8 keys, if you could call them that. You have the left, right, up, down, select, start, A and B button. That's it. So you have a very limited set of input parameters, and you can only show 8 sprites per scanline. That is very little, especially if you think about all the sprites consisting, like they would call them meta sprites. Usually an image like Super Mario consists out of 4 sprites. So on one scanline you would already have 2 sprites for the feet, and then on the second line there will be 2 sprites as well. And then there's the enemy, and there's another enemy. So if you would have more than, like, say 6 enemies, you would have to do something with like turning off one of the images at some frames. So some images or some games, they look like they're flickering. That's the only way to play that game. Otherwise it wouldn't be possible to show all those images. Okay, so and then finally, because programming for the NES is already so super easy, they also split up the 2 ROMs. There's a character ROM and a program ROM. You can actually see them here on the chip. One holds all the sprites, and one holds the code or the software. Okay, so let's learn you some 6502 assembler. So before we can start with this talk properly, we of course need to learn some assembly. Who here has done any assembly programming in his life somewhere? Some, yeah? Okay, cool. And what kind of assembler is it? Like pre-90s or post-2000s? What like who did like MEI MIPS or ARM x86?
No, just Z80.
Z80, oh, of course,
Z80.
just Z80. Z80, yeah?
Yeah.
And who else? Z80? No? You know what Z80 assembler is a language for Game Boy, for example, or the MSX or Master System, Sega Master System or Sega Game Gear. Yeah. Who else did some assembler? What kind of assembler?
I did it on an Acorn Electron on the BBC Micro with the
Oh, cool.
assembler built in
Okay,
basic.
which is 6502, I think. Yeah. Someone else?
Yeah,
What?
a long time ago, can't really remember.
Okay.
But I made a chat protocol over a printer.
Whoa, cool. Wow. So your printer could chat back to you? So you would print something? Oh, that's great. I should step down probably. Okay. Anyways, 6502 assembler is pretty easy to learn if you're into assembly. Also, if you're not into assembly, it's actually a pretty easy assembly language to learn. And we're going to do this now. So imagine you have a variable in JavaScript which looks like this. For var a is 3. And now you want to do store this into the memory. JavaScript does this for you. It stores the 3 to the point where you have the a thing, you know, and you next time you want to have a, you just call a. With assembly, you don't really have variables. You can have like byte words, but you don't really have variables. You just have like places in the memory somewhere. So you have to put something in a specific place in the memory. So we load the number 3 into the accumulator A, which just means like we store 3, the number 3, in a certain location for like just a period of time. And then we store whatever is in A, which is now 3. You still with me? Yeah. So you load the number 3 in A, and then you store. This means load in A this thing, and this store in A. Store whatever is in A in this thing. So now we store whatever is in A in memory location 0 to 100. Who here is very good at what do you call it, hexadecimal counting? What is A200? It's super easy. If you know, it's not super easy. If you know hexadecimal counting, it's easy. Which is So this first number means like everything. This is the 16th thing, and this is the 16 to the power of 2, so 256, right? And this means
Power of 3.
yeah.
1, 2, 3. Yeah.
I think it's 512.
I use converters.
I think 512. Doesn't really matter. In JavaScript, you can also count hexadecimally, which is fun. You can just go 0x200. Let's do that. Actually, otherwise we can't know for sure. So we go to the terminal and open Node, because that's JavaScript also. And we're going to go like this. 512. Yes. Okay, we're right. Cool. So now you can also do hexadecimal counting in JavaScript. Yay, you learned something. So next time you would access that A variable, you would actually have to load in A, not this number, but you would have to load this registry. So it's like I put the number 3 here. Let me put it here. This is 0200. I'll come back to it later when I call A, but now I don't call A. I load in the accumulator. I load 0 to 100 again. Okay, I have it. This is 3. Yes? Okay, so as you can see, I just got into teaching. I'm not really good yet. So this is what you call, how you can do a loop in 6502. It's already a loop like we know them, like for loops and while loops. But this is what, like, you can do something like looping in 6502 number, and you would go like this. So, for example, we want to have a for loop that runs from I is 0 to 16, and then after that it does some other stuff. So I added some stuff in the some things in the assembler code. So I have the init, which runs this. This just means jump to subroutine, so it calls a function sort of. So it would do this, and it would load the literal value of 0, so 0 in the accumulator x. So now again we store something in a place, but now we store 0 in that place. And then we say return from subroutine. Okay, so it goes back to this place. And then we jump to for my first loop. So my first loop does this. It increments the number which is in x. So first the number was 0. Now we increment it with x. We increment the number in x with 1. So now it's 1. Yes? Still with me? Some of you, hopefully. So now it's 1. Then we do cpx, which means compare x with 10, or not with 10, with 16. Of course, because it's hexadecimal. Let me just show you that I'm not lying. Yes, okay, it's 16. And then we check if the number is already 16 or not. If it's not 16 yet, we go back to this, it's called small loop here. That was a typo, I'm sorry. It should actually be my first loop. So it goes back to my first loop. Yeah, so we increment with number with 1, then we compare if it's already 16. If not, we go back to the loop and we increment it again. We compare it with 16 again and we go back. If it's done, it will just go to the next line, which is return from subroutine, and it would start doing stuff here again. And then it would do the other function.
You don't
Yes?
have to do any of your own stack handling.
I'm sorry?
You don't have to handle your stack.
With 6502?
Yeah.
No, it's super easy, I told you. 6502 is like, it's mega easy. Okay, so, but nothing is cheap on a 2 kilobyte RAM device, because you only can do things that often, and you only have 50 frames per second to do it. Like, it's kind of, everything is kind of tight. And unexpected things happen. So the first time I was doing this, I wanted to load the background, and the background is about 256 by 240. And every background tile is 8 pixels, so it came about like 1,000. It would have to do this 1,000 times to load the background. So I made this for loop. It's not exactly like this, but this is a nice example to show you. This is the exact same thing as I had, even with the same typo, like you see small loop there. It's the exact same thing as the previous slide, but it didn't work. Can anyone tell me why? So I would have to loop from 0 to 320, then I do stuff. Yes?
Maybe this is an 8-bitter?
Yes, it's an 8-bitter. That's the problem I encountered, and I didn't know what an 8-bitter was until I encountered it. So with 8-bit, you can only count to 255. So what happens if you increment this number with 1 after 255, it just becomes 0. So you start all over again. So I had this background and it only like showed stuff at the top. And then after a while I was like, ah, okay, of course it only shows stuff at the top because the number is back to 0. So those are things yeah, you have to learn by doing, I guess. So doing trivial things in 6502 assembler and in Nest development is kind of hard. I wanted to do like loaded background, which wouldn't be that hard, but after a while I only found out what the problem was, and this guy would have probably figured out immediately. It's like, of course it's an 8-biter, come on. So I thought, okay, well, assembler is probably not really for me. There are people who like it, but maybe it's not for me. So I thought maybe I could do like abstract syntax tree analysis and write some JavaScript code, which is way more easy to do this than writing 6502 assembler, I thought. So I would do abstract syntax tree analysis and look at the JavaScript code I make, let it read it, and then it will produce assembler to replace that. So how would that would look like this. I would write this JavaScript code, set background palette with a few numbers, and then when I would run the compiler or the transpiler, I would basically made a Babel for like 6502. It would, but with the help of Michael Matuzek, by the way, he wrote like most of it, and then I polished it a bit. And then I would run this, and this would come out. So this is all of the data. So this data is here. And then I would have this little loop that would load the palette in the right place. Because with Nintendo, and especially like with all these old devices, there is certain stuff that needs to happen in certain places. So you don't just load the palette somewhere. You load it in the right place. You load it in that place which knows which color will produce. So there's a specific place where you can go to load the colors, and that's at 2007. Yes? Okay, remember that. No, you don't have to remember that at all. Okay, so I found this open source abandonware. I found someone's abandoned project on the interwebs of things, and it was like somewhere on NPM I found this compiler that did some JavaScript analysis and then made 6502 assembler out of it. I was like, okay, cool. I don't need to do that much work. So I took it and polished it. With the help of my friends, like the guy who wrote it himself. He said you should probably not use it, but yeah, sure, you can go and edit some and add some pull requests. Sure. So I made something, and I think it's time for a demo, because I've been talking about 6502 assembler way too long. So I prepared a little demo, which shows you that Nest development is just similar to writing software for the browser, because you have to like reset everything. This basically does like a CSS reset, almost. Like it just says, okay, colors are black, nothing is in memory, now you can start. If I write this function, the abstract syntax tree would analyze my file and then would parse my JavaScript and then replace this little sentence with some assembly. So I can show you how that works. Yes, so this should probably be bigger, right? Like this? Is that good?
Yeah.
Okay, so I made, it's a JavaScript project, so I have some packaged JSON NPM scripts. I say start, and would run it would go through the JavaScript and output an assembly file. So this is the assembly file. Nobody wants to read that, but and actually it would, in the end, the assembly file could be compiled, and then you could run it on your NES. So let's do that. I didn't actually bring my NES because there's already too much stuff going on in this talk. I am doing live demos, and my NES broke down like 3 times on stage, so I quit that. So now I don't know if anyone knows of a better way to run an emulator on Mac, please tell me afterwards. So I run this. Okay, now this comes out. Okay, and let's change the background palette. Yeah, I saw Kirby. That's actually already like made a mistake. This is already part of the next demo, but that's fine. Okay, so this is a Nest color palette. As I told you, it has like a number of duplicates there on the right side. You can't actually see them. So if anyone would call out a number, please. We have, what do we have now, 2A or something? Okay, so this is the background, 03XB. So that's this color. Can anyone give me a color that's a bit different from that?
1C.
1C. Okay, sure. Let's do that. So, oh shit. Sorry. I had to, like on Mac, everything was with a command, and on my Linux, everything was a control. So, what did you say? 1C, right? Right?
Yeah.
Okay. Let's do 1C and see what happens. So now we run it again. This thing tells me another game was imported. Yes, the background changed. Okay, cool. So another demo?
Yes.
Yes, let's do it. So we can also change the background. So this is the background now, this thing. And we can change it because I made something that does that as well. So I actually made a package that can run, like you can use a map tile map editor, and you can just don't have to do this by hand now, but we have to do this by hand now because, yeah, sorry. Okay, so we change the background, we put some of JS logos here and here and here and here. Some letters maybe. Oh no, this looks like a platform. We can enter, yeah, there you go, platform. Save it. We can go to like the TMX file. It is actually just a CSV. Yeah. We copy this, all this. Yeah. So that's not really pretty, but it works, sort of. So we run build again, and we see the background changed. Yes, the background changed. Woo! I feel pretty excited right now. So one more demo, that was the sprite swap. I was actually going to put Kirby in, but now I'm going to take Kirby out. It will be sort of the same, right? So this is where Kirby was. How do you do that? Yeah. See, Kirby was there. Let's take Kirby away. Save this file again. I think you do that with, yes. Okay, this is a sprite I made, which is not as pretty as Kirby, but you know, what are you going to do? Yeah, and now I'm going to run the tile set converter and run build again. Go back to the emulator. Hey, we have a different character. Cool. So you can actually make something with this project. Although this talk is also about why you shouldn't. So I did this talk in Tokyo, for which Daijiro in the back of the room. He's really interesting. He has really cool projects with like making music on JavaScript and on the command line. So check this stuff out. But he invited me to come to Tokyo, and I did the talk there. And just a week after I did the talk, the guy who wrote the original transpiler wrote a blog post about like why it was such a bad idea. It's like crap. So I read his post and I was like, oh, really? That makes a lot of sense, actually. I can't. You should probably read it yourself if you're into it. But the basic, like the bottom line of the story was, if you start doing things you don't know what you're doing, which is fine, and then you start like you develop your knowledge and you do something else, and you're like, okay, I shouldn't have never have done that. Like I wouldn't use the HTML and CSS code I wrote when I was like 15 and implemented now in my new website. That's like a super silly idea. And the JavaScript I wrote 6 years ago is really, really like, don't even look at it. You'll vomit. So that's basically the bottom line of the story is you will learn a lot when you do stuff and then you develop your knowledge, but you should also evolve what you've learned and take your project to the next place. So I'm also abandoning that idea of transpiling, which was just a silly idea. It worked, but it wasn't really useful. that guy actually wrote something useful that is more or less a transpiler for 6502, but it's more, no, it's a compiler for 6502. So you can actually put assembler in there and something comes out that's a binary. And he wrote it in JavaScript on top of another compiler, which is pretty cool. So if you're interested in that, check that out. Also, he has some stuff about doing sound on the NES, which is great. Like you can do super easy, you could just like say C5, C3, and then you would have an octave going on your NES synthesizer. It's just like a JavaScript synthesizer with NES sounds. It's great. Okay, so do that. And program the NES in assembler or C with C65. So I made this prior to the conference. How much time do I have?
15 minutes.
Okay, I'll quit soon enough. So I made this for the conference. I don't know the buttons yet. So you can, this is like a slide machine. How do you, yeah, there you go. So this slide machine, it's a PowerPoint. And you can throw JSON at it, and you will have a PowerPoint slide you can run on the NES. So if you want that, that is actually a useful thing. That is something what came out of that, which was useful. And I made it in C, and I realized C is actually not that hard. It's basically like JavaScript. I mean, look at this for loop here. Where was it? Here. There we go. This for loop is actually a C for loop. You can also use it in JavaScript, but it's C syntax. Yeah, so it's not exactly like JavaScript anymore. You get the idea. It's not actually that hard to learn JavaScript, like C, if you're doing JavaScript or the other way around. So doing hard things is easy. That's what I'm trying to say. Like, it was because it's so much fun to do this. It was like super hard, and it was way too like I couldn't do this at all if it wasn't for my friends. But it was lots of fun, and I find that if I do trivial things, it's super hard for me to get the motivation and the energy to do it. But this was super hard, and it just made it easy because it was so hard, and it was a challenge, and I could go at it, and I would also get victories, small victories, which would help me. Otherwise, I would have stopped. Wait, like if it's too hard, it's not that easy. But if it's like hard at the right level, just like I think I can do this, just like Super Mario in that sense. I mean, whenever you play that, you're like, I can finish this game, and then like after 3 levels, you die. That's also like it gives you the feeling that you can do this. And doing hard things is especially easy if you know what you're doing. Which, in hindsight, now I sort of like what I did in April was very easy. But doing hard things is also easy when people are being nice, and that's why I want to take this time to thank the NES Dev community. That was super helpful. If you want to do NES development, you should go to the NES Dev forum. If you post a question, they will answer you within a day. Also, Michael Matuzak, that guy who I told you about, he's super nice and he's super helpful. And whenever I asked people things, they would help me out. And otherwise, I wouldn't be here. I wouldn't have made what I made if people didn't help me out. And that's also why I try to lower the barrier to entry to what I'm doing. So I wrote a blog post on how you can get set up with writing for the NES. And you should do that in your fields too. Like, lower the barrier to entry. If you just started, you probably know what was hard for you. Just write it down, and it will make things easier for the people that come after you. Thank you.
We have some time for questions.
Yes. If anyone cares to ask the question what I did. Yes?
Yes, do you know about the JS Mesh project?
No.
JS Mesh is basically a translation of the main emulator
Okay.
that is based on that's being used in that Mac program you're using.
Yeah.
That's actually using AMP scripting to convert it into JavaScript again.
Okay.
So I think it might be like a really nice demo if you use your JavaScript to make a NES ROM and then you run that NES ROM in main compiled into JavaScript so that you can actually use it. So basically archive.org has a lot of NES ROMs that you can play online with that project. So I think it's nice to
Cool. Thank you. Yeah. Anyone else? No? I'll put the slides up online, and I'll also put links to the right things that you would like to check out, maybe. Like the Getting Started guide I wrote, and also this ROM, and the repo I made, also the ROM and the repo I made for like the JavaScript part, but also like the PowerPoint. I'm just gonna rename it and name it PowerPoint.nes. I think that sounds cool.
I have a question.
Yes.
So there is a NES dev community still
Yes.
happening.
Yes.
So are there actually still games being?
Yes. So this is the greatest thing that happened. Like, so I found the community and I was like, okay, well, probably nobody is making NES games anymore, but they are. Like, many people still making NES games, and they're still coming out. You can buy them. They're not cheap at all. They're like $50 a pop, which is super expensive. But then again, like it cost me like $60 to get this running, so it makes sense that it's not cheap. There's a guy that's very active in the JavaScript community and called Dustmop, @Dustmop, and he's writing a game called Star Versus. And he released that, and it's pretty cool. And he's making a new one, which is a 4-player multiplayer NES game, which actually runs on the NES and it requires super difficult hardware. And like this will not be able to cut it. Like you will have like all these memory banks. So there are still people making it. There's actually a competition going on. Like it's not like a game jam or like Ludum Dare, but it's there's a competition that will end on the 31st of January. And that's the entry date. And you can upload your own ROM, your own NES game, and you can either win $128, $256, or $512 if you're first prize. Yeah. So yeah.
Actually,
so
I have a NES,
yeah.
and not the new retro ones, but I actually bought it brand new back in
Oh,
1985, I think.
cool.
So, thanks for making me feel old.
Yes. Much obliged.
Thank you.
Yes. Okay. Thank you.